Welcome Math 107 students to the preview exercises for Lesson 6, which is Linear Models and Applications Day 2. So we're going to continue to work with linear models and their applications similar to what we did with Lesson 5, but now we're going to be using two variables to help us. And so we're going to do a little introduction to working with equations that have two variables in them, and also looking at two of these equations at the same time. And this will help us solve some of the story opportunities that we look at in this section. So this section involves some more of the problems from section 1.3 and the material from 1.3, but it also introduces us to some material from section 5.1. So again, as usual, I hope you've had a chance to look over some of these preview activities and try them, and now we'll take a look at them together. So the first question asks us to determine if the following statements are true or false. So notice 1A gives us the ordered pair 4, -1, and 4 is going to represent our variable x in this case, and -1 will represent our variable y. And we're asking, does that ordered pair satisfy this equation? Now notice this equation is different than what we've looked at so far because it has two variables in it. It's a linear equation because you don't see any exponents higher than 1, and we call it a linear equation in two variables. So what do we mean by does it satisfy this equation? In other words, we mean, does this value of x equals 4 and y equal -1 make the left side equal to the right side? In other words, is it a solution to this equation? So the only way you can check that out is to replace x with 4 and y with -1 and see if the left side equals the right side. So the left side comes out to be 4 take away 2, which is 2, and that equals 2. You're a happy camper. It is true. So the first one is true. So 4, -1, that ordered pair is a solution to that equation. The next part, B, asks us if this point could also be a solution to this linear equation in two variables. Does it satisfy this equation? Is it a solution? So let's check that out. 4 take away 2 times -1, that equals 4 take away a -2, which is 4 plus 2, that's 6. Yep, it certainly satisfies that equation as well. Doing double duty here, huh? So the next question says, is this ordered pair 4, -1 a solution to this linear system? So this might be a new vocabulary term for you, a new idea. A linear system is when we consider more than one equation at a time. So in this case, we have two linear equations with two unknown variables, or two unknowns. So when we look at two equations simultaneously like this, we're trying to find, if possible, an ordered pair that satisfies both of them. And since 4, -1 was a solution to both of these equations, we say it's a solution to the linear system, so that's true. So now we're going to take a look at all of this visually. We're going to look at graphing this line and graphing this line, and then we're going to see the relationship between 4, -1 being a solution to both of these lines, and visually what that looks like. So let's take a look at graphing these two lines. And whenever you have lines given to you in what we call the general form like this, there's really no need to go back and convert everything to the y equals mx plus b mode. In fact, when it's handed to you looking like this, the hint that we give you up here in the exercises is to just find the x and y coordinates. It's very quick and easy. And if you have 2 points and you found them correctly, then you can get a straight line. So let's find the x and y intercepts for this first equation here in red. So I know that with my intercepts, x is going to be 0 and y is going to be 0. So in this first case, we have our y-intercept. This is our y-intercept. So I'm going to let x be 0. And when I let x be 0, I get 0 plus 2y equals 2. So y must be 1. That's really quick. and you can go to your graph and put 0, 1 right in there like that. Now it's it's y's turn to be 0, and that's going to be the situation where we're looking at the x-intercept when y is 0, because the x-intercept sits right along the x-axis, so y is 0. So now I let y be 0, and I get x equals 2. So 2, 0 is my x-intercept. So that's how quick you could graph this line. So then you just put a line through these two. Oh, and I didn't do a very good job, but I'll move it. Let's see if I can move it. There we go. No, I think I have to start all over. Let me cut it. Maybe what I'll do is just connect these. By hand, instead of trying to be too fancy. There we go. Just like you would do it at home. Okay. So, and you always want to label your line. This is a line x plus 2y equals 2. Just like you always label a title when you have a graph. Now, x minus 2y equals 6 can be done the same way. Find the y-intercept and the x-intercept in any order you want. You could do the x first if you wanted the y first. It doesn't matter. Again, the x-intercept, the y-intercept x is 0, and for the x-intercept, y is 0. So when x is 0 here, we get 0 take away 2y equals 6. So we get negative 2y equals 6. So y equals negative 3. So now I'm going to plot 0, negative 3. Now for my x-intercept, let's go back to this equation. Y gets to its turn to be 0, so you get x take away 2 times 0 equals 6. So x is 6. Oh, nice and easy. X is 6. So now when you connect these 2 points with a straight line, notice you'll intersect at the point 4, negative 1. So that intersection point, when you graph the two lines, is the same as the solution to the linear system. So they intersect at 4, negative 1, and 4, negative 1 falls on the red line, and 4, negative 1 falls on the blue line. So it's a point they have in common. I hope that helps you with any questions you have in these preview exercises. Please feel free to email me if you have any questions.